This is The Legend of Zelda: Tears of the Kingdom, a game known for its expansive and beautiful world, widespread quests, puzzles, combat, and creative gameplay mechanics. But today, we're going to talk about something a little bit different: physics. Let's get started. Today, we are covering Newton's second law of motion, specifically that an object's acceleration is dependent on its mass. This is going to get very interesting. Here, we have a wooden box that has a height of 2 meters and equal sides. We are going to be assuming that it is made out of oak, as it is a relatively common wood. To find our box's mass, we will first multiply its height, length, and width to get the total volume, and then take 2 meters subtracted by 2 times the wall thickness, because there are 2 walls, to get the length of the inner side walls, which we can cube to get our empty volume. Now, subtract the total volume of 8 by the empty volume of 6.1627 to get 1.837 cubic meters. Then, the mass of oak is 750 kilograms per cubic meter, so multiply it by our volume and we get a final mass of 1,377.75 kilograms. Now we can take 4 of these boxes and use Ultra Hand to fuse them together. This will allow us to measure the board we will use for our experiment. We can see that the board is equal to the 4 boxes, making it 8 meters long. To start the experiment, we will push the box the full length of the board, in which we get an average of 6.13 seconds. Since we have the time needed to cross 8 meters, we can figure out the acceleration. Let's use this kinematic equation to get the job done. S is the distance traveled, A is acceleration, and T is our time in seconds. Set the equation to solve for acceleration, then plug in our values. 2 times 8 meters divided by 6.13 seconds squared, which gives us 0.426 meters per second squared. Then to find our force, we use the equation F equals mass times acceleration. So multiply 1,377.75 by 0.426 to get a force of 556.92 newtons. After that, we can start creating our higher mass object. Let's stack these boxes and put them next to the poles. The poles are equal to this, which means that they are 4 meters tall. And since there's 4 of them that span 2 meters, each of them is 0.5 meters wide. For the pole's mass, we do the same as with the box and multiply the height, length, and width together to get a volume of 1 cubic meter. Then, that times the mass of oak gives us a total mass of 750 kilograms. Add that to the box's mass and get a mass of 2,127.75 kilograms. Now that we've added the pole to our box, we can repeat the experiment. This time the box is very clearly moving a lot slower than before. The average time to cover the distance for the bowl is 9.74 seconds. Now, we use the same kinematic equation as before with a new value for t to find the acceleration, which gives us an acceleration of 0.169 meters per second squared. Then, using F equals mass times acceleration again, we get 359.59 newtons. This may seem a little confusing at first because it shows that the force required to move the lighter object is higher than that of the heavier object. But the reason for this is the amount of friction acting against the objects. When an object has higher mass, it creates higher friction because it is pushing harder into the ground due to gravity, which is also why the acceleration for the bowl is less than the box itself. The friction resisting acceleration is higher. So, it's the same force subtracted by different amounts of friction, leading to different net forces. That's all for today's lesson. I hope you enjoyed and learned something new. Make sure to come back next time when Link and I decide to go over more physics. Alright, see ya.